Okay, so in this video, we're going to find the side length of our different areas. Again, just like we did last time using the square root function. The problem with this one, though, is they're not going to come out to nice, perfect numbers. In the last slide, you'll remember that we came out with some pretty nice numbers like 8, 3, 10. These side lengths are what we call rational sides because they're natural numbers, they're whole numbers. You can write them as fractions. They're going to be rational numbers. The problem, though, is that it doesn't always work out that nicely, especially if you have an area with a 32. This is where it starts to get a little bit difficult. So we're going to go through the same step, though. I'm still going to click down here underneath my formula, and let's put 32 in here. But when we go to the calculator this time, and let's put in the square root of 32, you'll notice it doesn't give us a nice perfect number. In fact, it gives us this really big decimal behind it. This is called an irrational number because it's not going to be a perfect number. It's not going to be exact. Compare that to the one above it, 10. If I were to type in 10 times 10, I would end up with exactly 100. However, if I were to take the square root of 32, 5.65685429, and multiply it by 5.65685429, you'll notice it does not give me exactly 32. It's going to give me 31.999999999 because this is a rounded number. It's going to be an approximation. It's not exact. And because we're dealing with rounded numbers, we cannot call them rational. And so what we do instead is we call them irrational. So this is where we're going to start looking at our irrational numbers. Now, I can round the square root of 32. Again, when I came back over here, I could say it's about 5.7. So when I click down here in the slide, I'll say about 5.7, but that's about as close as I can get. It's not going to be exact. So your irrational squares here are not going to be exact numbers. They're going to be giant decimals, and they're just going to kind of be close enough. Let's look at the next one here. If we had an area of 78, again, I'm going to go ahead and put this in my square root function here, 78. And when I go to the calculator over here, I'm going to say the square root of 78. Oh no, it gives me a really big decimal again. So here we have another irrational number. And I'm going to have to round this to about 8.8. So I can round this to about 8.8, but that's as close as it's going to get. It's not going to be exactly 78. And then the last one here, let's take the area of 15. And this time again, I'm going to put 15 in my formula down here. So the square root of 15, type that in. And this time when I go to the calculator, the square root of 15 is going to give me about 3.8729, which we can round to about 3.9. So it's, again, not going to give us an exact value. It's going to be close enough. And those are going to be what we call irrational.